Welcome back. All right, we're going to divide now. The same rules apply for division as they did when you were in elementary school. So to divide fractions, you multiply by the reciprocal. So you can see an example worked out in the top right of your screen of how we keep the first fraction the same and then we change it to multiply by the reciprocal of the second. So we're going to have to rewrite what we see and then we'll factor, cancel, and multiply back together. Those will be our steps. Okay, so the first one I keep the same. I keep the 5x to the fourth over 8x squared y squared. And I'm going to multiply by the reciprocal. So I'm going to flip that. 8y to the fifth over 15. And now I'm going to cancel out some common factors. I see that 5 and 15 have a common factor of 5, so I'll have 3 left down here. 8 and 8 cancel. And then here I will have x to the fourth over x squared, so I can subtract these exponents. 4 minus 2 is 2. And then I've got the y squared and the y to the fifth. There are more y's on top. 5 minus 2 is 3. All right, so it looks like if I look at my numerator, it looks like I just have x's and y's, and it's an x squared y to the third. And in my denominator, there's nothing left here. I just have the 3. It says assume all expressions are defined. So once I divide and simplify, I'm done. Okay, let's try some with polynomials in them. Okay, so I think when I rewrite these, I'm going to factor them at the same time, okay? It'll just save some writing and hopefully feel like a little bit less work. So this first fraction is going to stay the same. I'm just going to rewrite it in factored form. So I will, looks like I'll factor out an x squared. All right, the bottom one. What multiplies to 3 and adds to negative 4? Looks like that would be two negatives, negative 3 and negative 1. Something else I'm noticing is that my numerator, I can keep factoring that x squared minus 9. That's a difference of 2 squares. So I'm going to keep that x squared in front and then factor the x squared minus 9 to x plus 3 and x minus 3. All right, times. Now I'm going to take the reciprocal. So I'm going to first factor the x squared minus 16 because that'll be my numerator. And that factors to x plus 4, x minus 4. Remember, we just take the square root of them when we're factoring difference of squares. And my denominator, it looks like I'm going to have a similar situation again. I see x to the fourth, x cubed, x squared. I can factor an x squared out, but then I think I'll have to keep going. So x squared leaves me with x squared plus 2x minus 8. What multiplies to 8, negative 8, and adds to 2? What would that be? 4 minus 2, x plus 4, x minus 2. So yep, those multiply to negative 8, add to 2. Woo! Isn't it great that we love factoring so much? And we practiced it so much second quarter. We're just like experts at it. And remember, if you're not an expert at it, go back to those videos from 5-3. It's all here on this playlist. And the factoring review videos. All right, let's cancel everything we can. So I'm going to look top and bottom first. I see x minus 3, x minus 3. X plus 4, x plus 4. I remember I factored out those x squareds. Those are diagonal from each other. Anything else? I'm going to highlight what I see left over because this is looking kind of messy. Anything else matching up? Nope. That means we're ready to multiply and write out our answer. So our answer is x plus 3 times x minus 4 all over x minus 1 times x minus 2. We're assuming everything's defined, and you can leave your answer in factored form. I think your textbook rewrites it in standard form. You do not need to do that. Okay, you can just leave it like this. All right, last topic of the day, or of the week, I should say, is solving equations that involve these rational expressions. So we're going to go through these same steps. We are going to factor what we can, cancel what we can, and it'll make the solving very simple after that. So before we get started, let's look at this caution tag. It says, as you simplify a rational expression, take note of values that must be excluded. The excluded values are those that make the rational expression undefined. So if I look at this first one, what makes this undefined is what makes the denominator 0, which is 5. So x cannot equal 5. So if we end up with the solution of 5, we may have no solution. So let's factor first. X squared minus 25 is a difference of 2 squares. X minus 5, x plus 5, all over x minus 5 equals 14. Well, I can cancel these x minus 5s. So I have x plus 5 equals 14, minus 5 from each side, and x equals 9. Doesn't that feel better than those previous examples? I know that you probably thought solving was going to be harder, but that's not necessarily true. One more, and I think we'll wrap things up for the week. All right, let's factor that numerator. Also take note that x cannot be positive 2. All right, so what multiplies to negative 10 and adds to 3? 5 and 2, 5 minus 2. So x plus 5 times x minus 2 all over x minus 2 equals 7. These cancel. X plus 5 equals 7. Minus 5 from each side. X equals, uh-oh. What happened? We got a solution of x equals 2, but we said back at the beginning that x cannot equal 2. If that happens, what you have is a situation where there is no solution. There is no value that makes this true. And if you don't believe me, take a minute and substitute that number 2 in for x. Substitute it in all 3 spots and see what happens. You will not get a true statement. Okay, to summarize, what 3 steps should you use when simplifying, multiplying, or even dividing rational expressions? What 3 steps hold in all of those situations? Factor, cancel, multiply. Good job. Your assignment this week, I know it looks like a good chunk of problems. Some of them will be fast, some of them will be a little bit slower, but let's be honest with ourselves. We probably need the factoring review because this is not a standalone skill this week. We're going to keep needing the factoring skills through the whole rest of this chapter, okay? I hope you're having a good start to your week, and I'll see you in class and in office hours. Take care.